Hey, Professor Caps. Hope your night is going well. This is Michael James, and I'm performing my acid-base reaction. So I've went ahead and prepared a couple things that I want to show you. So first, on this plate, I have some baking soda here, and I've got it. I'm going to fold it up in a paper towel, and I'm going to put it in this jar. So I don't know if you can see this. So there's my jar. I also have some vinegar here. And I'm going to perform this reaction with some precautionary measures because I'm not sure how much of a reaction we're going to have. So I'll point this down so you can watch me perform it. If I run off screen because I have too much overflow, just know that it's just to protect my computer. So you can hear the fizz. Oh, wow. So I wonder if that the paper towel kind of controls the reaction a little bit. That's what I'm thinking here. Because we're seeing some obvious fizzing over. Let's see, there we go. Now, part of me wonders if I capped this bottle, if the pressure would build up and the glass would break. I'm not sure if this reaction is capable of producing that much carbon dioxide, but just a thought. Looks like our reaction has slowed a little bit. I'm going to put it off to the side while I explain what just happened. Let me just reorient my camera here. Okay. All right, so baking soda and vinegar will react due to an acid-base reaction. I kind of went into that a little bit earlier. But in an acid-base reaction, the acid and base will react to neutralize the acid and base properties while producing a salt. So in our experiment, baking soda is a bicarbonate base and vinegar is a diluted acetic acid. So baking soda is a base and vinegar is an acid. An acid is a chemical that wants to get rid of a proton in the form of a positively charged hydrogen atom. A base is a chemical that accepts a proton. When we mix acids and bases, exciting things happen because we match a molecule that readily gives away protons with a molecule that readily accepts them. So in our case, the vinegar is a watered down acetic acid. Water acts as a host and a solvent in which the acid and base can dissociate into ions and then react with each other. In water, baking soda will break apart into positively charged sodium ions and negatively charged bicarbonate ions. When mixed, the vinegar will donate its proton to the negatively charged, broken apart baking soda. Together they form sodium acetate, water, and carbon dioxide. So now that I've discussed what products are formed from the reaction, I'm going to talk about how the reaction occurs. So the observed reaction happens in two steps. First, there's a double displacement reaction in which the acetic acid reacts with the sodium bicarbonate to form sodium acetate, which is a salt, and carbonic acid. So secondly, the carbonic acid is going to be unstable and it's going to undergo a decomposition reaction to produce the carbon dioxide gas, which we saw through the fizzing, and also water. So if you notice, the chemical reaction created a fizz as the carbon dioxide was released as a gas. All right, thank you.